Hello all. In the last couple of videos, we have been discussing about the reactions related to organonickel reagents. Okay, we have seen alkene-alkyne oligomerization and also the coupling reactions, which involves organonickel reagents. In this video, I shall explain to you two reactions, that is carbonylation and carboxylation. Now, both involves in addition of carbon monoxide. When you add carbon monoxide and if you get a carbonyl group, you call it as carbonylation. And when you add carbon monoxide and when you get a carboxyl group, you call it as carboxylation. Alright, now here we are adding carbon monoxide to alkenes and alkynes. Alright, let us have an example over here. You have this the carbonyl group is added to the allyl bromide. You get the acyl bromide or 3-butyenoyl bromide over here. The carbon monoxide is getting inserted between this carbon and the bromine. Okay, so here you can see here the carbon monoxide is getting inserted between this carbon and the bromine. So how is this happening? What is the mechanism behind this reaction? Let us see. Now we have here the nickel tetracarbonyl. Now nickel tetracarbonyl loses one carbon monoxide and you get nickel tricarbonyl. Now we have the allyl system. The allyl halide is here, bromide is here. Now the first step is oxidative addition, and there are two proposed pathways for oxidative addition. In the first pathway, the double bond of the allyl system gets coordinated to the nickel tricarbonyl and you get this neta-3 allyl system, allyl complex. Okay, so here the double bond of the allyl is getting coordinated to the nickel. The second pathway proposes that the bromide is getting coordinated to the nickel and you get neta-1 complex, allyl complex, neta-1 allyl complex. Both these are 18 electron system. And these two are interchangeable with the removal of a carbon monoxide or addition of a carbon monoxide. You add one carbon monoxide molecule to neta-3 system, you get neta-1 system, and you remove one carbon monoxide moiety from neta-1 system, you get neta-3 system. Okay. Now, the next step after oxidative addition is migratory insertion of carbon monoxide. Now, when the migratory insertion of carbon monoxide in the neta-3 system happens, we get 14 electron acyl complex. Okay, we get unsaturated 14 electron acyl complex. It is this one. But when the neta system undergoes migratory insertion of carbon monoxide, neta-1 system, when it undergoes migratory insertion of carbon monoxide, we get 16 electron acyl complex. So when neta-3 undergoes carbon monoxide insertion, you get 14 electron acyl complex. When neta-1 system undergoes migratory insertion of carbon monoxide, you get 16 electron acyl complex. Now, after the migratory insertion, the next step is reductive elimination. Now, in reductive elimination, what happens is you get a product is formed here. The nickel tricarbonyl is removed. Then, how is it happening? One carbon monoxide gets added up over here, and the nickel tricarbonyl is removed, and you get the product here. You have got the acyl bromide. So, this is the mechanism which has been proposed for the carbonylation, addition of carbon monoxide to alkene or alkyne using nickel reagent, organonickel reagent. Alright, now the next step or the next reaction which we are going to discuss is carbonylative cycloaddition of allylic halides and acetylene. That is, you are going to add allyl halide, acetylene and carbon monoxide together. See here, you have the allyl halide, acetylene and carbon monoxide in the presence of nickel tetracarbonyl. And you get a cyclopentenone ring over here. Cyclization happens. Alright, another example over here, we have a ring system, and the acetylene group is here, carbon monoxide is added, and you get a fused ring system. The 5-membered ring is being fused to this 8-membered ring system. 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, a 9-membered ring system and so on. Okay, another reaction, this explains the intramolecular cyclization. A compound which has a triple bond and a double bond in it can undergo intramolecular cyclization to get a fused ring system. The reaction will happen in the presence of nickel tetracarbonyl. Now this reaction is very useful and quite good, but the problem is the toxicity of nickel tetracarbonyl. So they do not take up this. Nowadays we do not carry out the reaction in the presence of nickel tetracarbonyl. Instead, we can use our NiCOD twice, okay, nickel cyclooctadiene complex. Now, another disadvantage of this reaction is that the product which we get a mixture of products, and also a lot of byproducts are formed. Okay, so to overcome these, we go for NiCOD twice. Now, how is this insertion happening? Now, how do we write the product? I'm not giving you the mechanism of this reaction, but how can you write the product of this reaction? Where is the carbon monoxide getting inserted? How is this double bond and triple bond getting reacted, etc. Just how do we write the product? I shall explain to you. Now, let us take up the first example. And one more point I forgot to tell you. When this reaction happens in the presence of water, we get ester, and if it is taking place, we get carboxylic acid, and if it is taking place in the presence of methanol, we get ester here. See, all these reactions are carried out in the presence of methanol, and we get an ester here, COOMe. Here you have. So this bromide, this halide is removed. Okay, here you can see this Br is replaced by COOMe. Here also the Br is replaced by COOMe. If it was water over here, you get COOH. Alright, that's the difference when you use water or MeOH. So for exams or competitive exams, you must be careful what is the solvent here or the reagent over here. Now, how can we easily write the product of this reaction? Let us see. See, here you have the first. I'm going to discuss the insertion of the first reaction. This one. We have the allyl system. We have the acetylene system, and we have the carbon monoxide. Now, let us say that the way how we can write the product is you bring all these three together. One bond from the acetylene goes to the carbon monoxide. From the carbon monoxide, a bond is formed to the allyl system, and from the double bond, the other carbon of the allyl system, the bond is completed to the the ring cyclization is completed to the acetylene system. And this bromine, if it is methanol, this bromine is to be replaced by COOMe. If it is water, this bromine is replaced by COOH. The C double bond O, triple bond O gets converted to C double bond O. See here, you can see here, this green bond, see here, this triple bond is getting added to the carbon monoxide, see here. And from the carbon monoxide, a bond goes to the allyl system, here. And from the allyl system, you get one bond to the acetylene, here. And cyclization happens. So that's the way you can write the product. Okay, and you must also remember that you have to change this one, the halogen part over here on the allyl system, to either COOH or COOMe, depending upon the solvent used. And you must remember that one of the carbonyl group of COMe or COOH is obtained from the nickel tetracarbonyl. Okay, now try to write in the similar way, try to write how this bond would have been formed for these two reactions. Just try to write it. Okay, if you don't get it, we shall discuss it once more. Alright, so triple bond to carbon monoxide to allyl system to triple bond. That's how the bond is formed. Okay, so the carbonyl group is getting inserted between the acetylene and the allyl system. Okay, so you have the double bond here, you have the triple bond here, carbon monoxide gets added up here. You have the double bond, you have the double bond, you have the triple bond, carbon monoxide gets added up here. See here. You just try to write it down and try to write the product formation for these two reactions. Alright, now next example which we are going to discuss is carboxylation, as I told you earlier. That is formation of carboxyl group on addition of carbon monoxide. Now here aryl iodides and vinyl bromides undergo carboxylation. You can see here, you must remember that it's aryl iodide and not aryl bromide will not undergo. Similarly, vinyl bromide undergoes. Okay, carboxylation. You must be very much sure, make it sure that it's not aryl bromide, it's only aryl iodide. It gets added to carbon monoxide in the presence of nickel cyanide. Okay, you get the carboxylic acid. See, this halogen is replaced by COOH. That's simple. That's the way you can write the product. Now here a phase transfer catalyst is used. Here you can see CTBA, that is cyanotricarbonyl nickel anion. CTBA is cyanotricarbonyl nickel anion. Okay, so that is a phase transfer catalyst. Now here also you have the vinyl system. Okay, vinyl bromide. The bromine is replaced by COOH. Alright, same reaction, same reagents you are using, nickel cyanide and CTBA. Okay. Another example, one or two examples for carboxylation. Here we have allyl system. You are adding carbon monoxide. You are using NiCN2 and TBAB as the phase transfer catalyst. And you can see the Br is replaced by COOH. Okay. Similarly, you have benzyl chloride. Okay, and you get the carbon monoxide. Carboxylic group is replaced. The chlorine is replaced by carboxylic. Okay, so here there is a sort of displacement or replacement or substitution of the halogen by COOH group. Okay, so these are the how many reactions did we discuss? Carbonylation, carboxylation. Okay, so these are the two reactions of insertion of carbon monoxide to organic compounds in the presence of organonickel reagents. Alright, if you have clarifications regarding this, please feel free. And also try to go through various books for getting more information regarding the reactions. Thank you for watching the video. Thank you.